I started drawing the architectures on paper and guess what? It works! I've only learned that I have to post my projects out there. I still have non-public, but I'll fix it very soon. Now regarding the agents. Agentic AI and AI agents are not the same. I didn't know that, but they are not the same because agentic AI, think of it as an autonomous brain. It does the reasoning, planning stuff within one big agent, whereas a multi-agent systems, they're like organizations of brains that are working together. They are, think of it as a small team that has a certain workflow, big or small, and each agent, each kind of employee does its own thing, and in like together they're forming this system that handles the whole workflow. So they're not kind of the same. Emphasizing on mass and multi-agent system, it can be useful when for example, a single agent cannot handle all the context and it requires more of them to make a good decision, or the context is or memory is too large so that it needs to be handled by many different agents, or simply because the specific task requires specialization. It's actually multi-agents patterns are divided into two types, into kind of handoffs and tool calling. In tool calling, if you imagine it, you have you make a request, it goes to the brain. That brain is your LLM, it is supervisor of all the agents that are available in your architecture. And so this is a centralized, like all routing passes through the central agent, that LLM, and that LLM decides which agent to call. For example, and this is called tool calling because that LLM, that main brain, it refers to those agents as tools. And so that one important thing to understand is that those tools, those agents, they do not talk directly to the user. They are given the request, they are given a task, and then when they perform that task, they send it back to the LLM, to the main brain, and then the LLM does the following steps needed. So just remember that the tools themselves, they do not do and talk to the user. They do not do all the conversation and stuff. They just do their thing and send the outputs back. There's another pattern as well, which is handoff. This is when one agent decides to give the task, to hand off the task to another agent that is more appropriate to that. This is a decentralized kind of control flow where agents can change their who is active, who is doing the thing. I'm personally aiming at AI systems for enterprises. I am heavily into different architectures right now, reading papers, etc., especially building as much as I can because I really, really believe in it. And you see, the context engineering is at the heart of a good, of any multi-agent system. I'll be saying mass because it's easier. Deciding, this is, if you are thinking about what role it plays, is deciding what information an agent sees at a given point of time. So I work with LangChain, and it gives me, I don't know how any other frameworks work because I try not to spread my attention out too much. But LangChain gives you this kind of control over which part of information each agent sees at which point of time. It gives you this specialized, you can specialize your prompts for each agent, and this you can kind of decide the inclusion or exclusion of this intermediate reasoning that happens between agents as they during the workflow. So the quality of the system heavily depends on the context engineering, and just the main goal is to ensure that the agent sees the right information at the right point of time, whether it's acting as a tool or as an active agent. One thought that comes to my mind is that multi-agent systems, they turn AI that act into AI that collaborate. And say, for example, GPT-5 Codex, it will never ever design you as sophisticated UI as Claude Sonnet 0.5 will do for you. And it makes me to this kind of, it leads me to this point that multi-agent setups are powerful because you can have agents using different models and different reasoning kind of styles at different point of time. One checks and complements the other. You get better results by stacking them together. Multi-agent systems are powerful in itself because you don't need to give every single task to one agent and trying to expect the output as if it's a specialist in every single domain. It cannot, because there is even mathematically proving a theory which I forgot the name of. In 90s, I guess it was released, the papers that says that algorithms, they will average out if anyways. And just my point is, use multi-agent systems for complex tasks. And well, obviously, if you compare it to agentic AI, once again, to multi-agent system, agentic AI is like a muscle. It's strong, it's fast, and it gets this stuff done. Whereas multi-agent system, it's a nervous system that collaborate, those small neural networks that collaborate with each other. Also, mentioning the part which I'm trying to build out, and I'm soon trying to expect from myself to release the MVP, is if it is MVP, not more, of in a kind of app, a system design app that does the system design for your AI projects. This is it's taken me 1 month to figure it out fully, but I'm trying to understand everything within, and I understand I can just turn on cursor and make a full plan and let it run in the background for hours and vibe code it. But at the end of the day, I'm quite apprehensive towards that approach, because you have to understand the architecture of your project fully from within. And I was making a post the other day about manual coding and AI assisted coding or AI fully done coding. It's like understanding those lines of code is just, it gives you confidence that it's gonna work, because when it won't, I don't want to tear myself apart trying to figure out what have I done wrong, what is wrong. Anyways, these are the lessons that this is the main lesson that I've learned among countless lessons during this week. So it has been quite a productive week in a sense, but very exhausting as well. And it's probably time to wrap it all up.